are doing well. Welcome to Engineering Hotspot. So on student demand, we have brought one topic called entropy. But before going to the topic, let me say one thing that we have started a new series. You can check the playlist with the name of important topics of GATE and IES. So in that playlist, you can see all the important topics that are going to come that are very required for the any competitive exams. So you can look into the videos. If you feel any doubt, mention in the comment box. So now it's time to start with the topic. Let us begin with the topic with the quote: "Be stronger than your excuses." So if you continue to make excuses in your daily life, you will be on the verge of failure and you will not get the success. So let us begin with the topic entropy. So before going to entropy, let me give some examples so that you can get a better clarification. So you might have seen that a cup of hot coffee cools down when you keep it in a room, but the reverse don't happen. Similarly, if you take an ice cube and keep it in a room, then it will melt after some time and changes into water. But the same reverse thing will not happen. The reason is entropy. So it means that every process proceeds in a certain direction, while the reverse is not possible. So this can be explained with the concept of entropy. The first, in both the examples what I have given, it satisfies the first law, but the thing is, it is unable to satisfy the second law. Second law basically gives a quantitative measure of the entropy, and entropy is essential to understand the direction of the reaction or any process that is going to happen. So basically, entropy is a state of molecular disorder in the system. In simple language, if you want to know what is entropy, then entropy can be explained with the probability. If the probability of something or anything is less, then there will be more uncertainty involved with it. Like if you are not knowing what is going to happen, means the probability is less, then you will not be able to carry out your work in the way what you are expecting. So the probability will be less, and that's why the uncertainty of any outcome will be very high. So that's what entropy is. So whenever there is entropy, there is more uncertainty, where there will be more disorderness in the system. So how we measure the entropy, or how we can understand the entropy? Basically, we have seen in first law of thermodynamics that energy transfer in thermodynamics can take place by two ways. Basically, energy transfer can happen by two ways. One is by heat transfer, and the second one is work transfer. This is the only two modes by which energy can be transferred according to thermodynamics. Okay. If something is, what is heat transfer? Heat transfer will be basically due to temperature difference. If anything or any energy transfer that is happening due to temperature differences, then it's called the heat transfer. And the remaining any form of energy other than heat transfer means if it is not due to temperature difference, then it will be considered as a work transfer. Okay. Similarly, entropy transfer can also happen by two ways, with the help of two modes. One is the heat transfer, and the second one is mass transfer. You might be surprised why I have not included the work transfer. Okay. But before going to that, let me say how heat transfer can result in entropy. This is basically the entropy transfer from the system or to the system. So how heat transfer can cause the generation of entropy or entropy in the system. So basically, whenever heat is transferred to a system, what will happen? The internal energy of the system will increase. Okay. If the internal energy of the system increases, then the the molecules that is present in the maybe anything like gas or something, molecules will gain kinetic energy, and due to that, uh, the molecules will collide more frequently, and it will result in more chaos or randomness in the system, and that's why the entropy of the system will increase. Similarly, in the same sense, if the heat is taken out from the system, then what will happen? The entropy of the system will decrease. So this is how the heat transfer causes the entropy. Similarly, mass transfer can also cause the entropy. Uh, Basically, mass transfer we will take when we deal with the open system. So, in for closed system, if we are saying entropy, then the only mode for entropy transfer will be heat transfer. Because in closed system, we know that there is only energy transfer, there is no mass transfer. But in open system, the entropy transfer will be both due to mass transfer and heat transfer. So, why I have not considered work? Why work don't cause entropy transfer? The reason is that the in work transfer, all the molecules are in ordered way or in ordered fashion. If you pull a string or rotating shaft, the molecules of the rope are so ordered that it will not cause any friction in the system, generation of any irreversibilities in the system, and due to that, the entropy due to work transfer will be zero. So you need to keep that in mind, that there will be no uh, entropy production or entropy generation due to work transfer. Yeah, one thing it can happen, like if the system is adiabatic and work is being transferred to the system, in that case what will happen? The work that is transferred, it will convert into internal energy, and the internal energy of the if the internal energy changes, in that case the entropy may increase or decrease. So in that sense, the entropy can be produced in the system, but with that work it will not produce any entropy. In layman language, if I want to explain what is entropy, then you can think like in a if you go in a library, and so many department books will be there, like mechanical engineering department books and computer science engineering departments book, and then electrical and so on. All the department books will be available in the rack accordingly. So in that case, it will be very convenient for you to search the book, and if the index is also given in that rack, like you can find this heat transfer book there, thermodynamics book to there, and then it will be very convenient for you to find the book, and you can easily discover the book. But if the things are not like that, if they have not stuck the department name or the book where you can find it, then it will be very time taking for you, and you will waste time and your energy as well. So in that case, what does it mean? It means that you are having a higher entropy. So it's always better to reduce the entropy. The organized person is, is such that they have less entropy in their life, and that's why they are successful. So you need to have a lesser entropy life to be successful. So so in this sense we can explain the entropy. And entropy basically, entropy, or sometimes it's called total entropy. is an extensive property. Okay, why it's extensive property? Because it depends on mass. Its unit is joule per k or some joule per k or kilojoule per k, anything. But if you take a specific entropy, then it is an intensive property. Specific entropy unit will be joule per kgk. Okay. And now we will try to solve in mathematical way. Remember, for any process to happen, delta S will change in entropy, because we can't determine the absolute value of entropy, and absolute value of entropy is very difficult to determine, and that's why we always go for delta S, like change in internal energy, change in enthalpy. Similarly, we are going for change in entropy. So that for any process to occur, delta S should be greater than equals to dou q by t for process 1 to 2. This is for a process. Okay. For any process, this should be valid, otherwise the process will not happen. Basically, this delta S is the sum of delta S for system plus delta S of surrounding. Okay. So you need to take delta S of universe. If you started taking delta S of system, then it will not be of any use. Delta S of system plus delta S of surrounding, you have to combine it, and then you have to find delta S of universe, and that need to be used for any calculation purpose. Okay. Delta S of system can be positive, it can be negative, it can be zero, depending on the situation. Never think like that delta S of the system should be greater than 0 or something like that. It can be positive, it can be negative. This can be positive, can be negative, or it can be 0 also. Similarly, delta S of surrounding can be anything. It can be positive, negative, or 0. But the sum of these two will always be greater than 0. Why? Because if you take the sum of this is what? This is, in that case, it will represent the entropy change of universe. And universe, we used to take it isolated, because the energy of the universe is constant, it will not change. The conservation of energy. So in that case, what will happen? This del q by t, you can take it as del q, you can take it as 0, because for isolated system, there is no energy transfer, there is no mass transfer. So delta S of universe is greater than equals to 0. So when to take equals to and when to take greater than, remember, delta S of universe equals to 0 only for a reversible process. Only for a reversible process. And delta S of universe is greater than 0 for any irreversible process. For any irreversible process. Okay. And if delta S of universe, if you are getting it as less than 0, then the process can never happen. Impossible case. As it violates the laws of thermodynamics and the law of nature also. So this can't happen. The process will not proceed. The reason is this. The two examples what I have given you in the initial stage, the same thing is applied here. Like as I said that a cup of hot coffee, when you keep it in a room, the coffee will cool down. But the reverse don't happen. The reason is this. If the reverse start happening, then delta S of universe will be less than 0. And we know that delta S of universe cannot be less than 0. The process can't be possible, or it's not possible. So it doesn't happen. So these are the things. And one more thing I like to say. Here you can see that delta S is greater than means delta S of universe is greater than equals to 0. So what you can do, if you are writing for a system, not for universe, suppose you are writing for a system, in that case it will be, you can write in this way. Now if you try to replace this inequality with the equation, in that case one can write this as 1 to 2 del dou q by t plus S generation. What is this S generation? Basically this part, what you can see, this 1 to 2 integration from 1 to 2 dou q by t, this is basically the entropy due to external interaction or external heat interactions, and this is due to internal things, or entropy caused due to internal irreversibilities. Internal irreversibilities. What do this mean? Internal irreversibility means basically due to friction, what you can't see. Friction, it includes frictions, okay. Everywhere the friction exists, and this is due to external. This is external irreversibility due to basically heat transfer, external heat interaction. Okay. So this is the thing, just what you can see. But there will be some problems where they will ask entropy generation, calculate entropy generation of this, that, and so on. So in that case, you don't need to break your head so much. Whenever they ask you the entropy generation, calculate the delta S for the universe, and the value of delta S for universe will be the value of entropy generation. So no need to break your head so much how to find this and that. Now I'd like to explain more about the entropy generation. So what is that? As I told you, that delta S is, if you replace this with an equality, then it will be 1 to 2 dou q by t plus entropy generation. Okay, this delta S is basically the change in entropy, and it's a point function. Okay, it is a point function. Point function means what? It will depend only on the initial state and the final state. It will not take anything in between the initial point and final point. Means it is not a path function like heat and work, though they too are path function usually. But delta S is not a path function, it's a point function. So you will get exact differential is possible. Exact differential. They are exact differential. So that's why I have, you can write this as delta S as ds as well, no problem. No need to use dou, like here I have used dou q because q is a path function, so you have to use dou because this is an inexact differential. Q is an inexact differential, okay. It's a path function. So now what about S generation? Remember, S generation is also a path function. It is not a point function, remember. This is very important. So here it is an inexact differential. Inexact differential. So you cannot integrate it because it's an inexact differential. Okay. So what you can do instead of this S generation is sometimes is also called as entropy production. Okay. It's also referred as entropy production. The name for entropy generation. In some book you can find they are writing entropy production also. So and one more thing I like to add, universe is taken as an isolated system. In that case what we have seen that delta S was greater than equals to 0. So whatever you do in your daily life, it will result in entropy of the universe. So the entropy of universe is continuously increasing by each and every person what we do in our daily life. It results in an increase in entropy of the universe. So much entropy has been increased day after day. So due to that, what happens? So much chaos is happening every day in the life, and this thing will happen till the thing reaches the equilibrium. At equilibrium, delta S will be 0. At equilibrium. So same thing will happen with our universe also. The entropy will go on increasing, and it will increase till it reaches equilibrium. Once the equilibrium is achieved, in that case, there will not be any increase in entropy. Basically, change in entropy will be constant. It will be it will take some value and then it will not change. So this is what we can see in the entropy portion.